In this section, we will have a discussion on the class D commutation and other types. So this is the circuit which will explain us about the class D commutation. Basically, the circuit is called voltage commutated chopper. Okay, this is a type of chopper circuit. You know what is chopper? Will convert the fixed DC voltage into variable DC voltage. Okay, here our aim is to discuss about the turn off of the SCR-T1. That's our aim. We need not to discuss about the complete operation of the chopper. That we'll discuss later. Now we'll discuss how the SCR is getting turned off. That's our aim. Okay. So if you go through the circuit, you can understand that this T1 RLE will act as a main circuit. This RLE is nothing but load. This RLE's combination is nothing but load. For example, if you take DC motor, in the DC motor, winding will be having its own resistance, inductance. So this R represents the winding resistance, L represents the winding inductance. Then what is E? Anyone? Can you say what is E in DC motor? What is the E in DC motor? Anyone please answer. Already you studied. E represents the back EMF. E represents the back EMF of the DC motor. So here you can assume that this complete portion is a DC motor. Okay. So what happens? A DC supply is connected to a DC motor armature through the thyristor. So this is the main circuit or power circuit. This is the main circuit or power circuit. Okay. And here additionally we have some other components. This capacitor C, TA auxiliary thyristor, inductance L, diode D will form the commutation circuit. This complete portion will form the commutation circuit. Okay. And we have other components. This FD represents the freewheeling diode. I mentioned here L, D and T2 forms the T2 means TA. T2 is nothing but TA commutation circuit. So TE1 is the main thyristor, TA is the auxiliary thyristor. Okay. So T1 and RL forms the power circuit. This FD is nothing but freewheeling diode. So about this I will explain in further classes. Okay. Don't worry about this FD and all. Okay. Now we'll discuss how the SCR. Now our aim is to turn off the SCR-T1. That's our aim is to turn off the SCR-T1. That's our discussion. Okay. Now we'll see how it is happening. Basically, it will happen in two different modes. In order to understand this commutation, we have to do certain assumptions. First assumption is we have to assume that switches are ideal, mean that the losses in the switches are zero. Second one is we have to assume that initially the capacitor is charged as per the polarity marked. If suppose the capacitor is charged, you can charge. That's why the switch and R is there. Initially, the thyristors will remain in the off state. Initially, both the thyristors will remain in the off state. Mean that there will be load will not be connected with the supply. Initially, load will not be connected with supply. Okay, but initially there should be charge in the capacitance. How we can do? Just by closing the switch. Just by closing the switch S, what will happen is the supply capacitor, the switch SR will form a closed circuit so that the capacitor will get charged. So initially by closing the switch S, the capacitor C will be charged as per the polarity mark. That's why the switch and R is provided. Okay. Okay. Let us assume that initially the capacitor is charged as per the polarity represents when main thyristor T1 is on. So let us assume that thyristor T1 is kept on. This is active circuit. This circuit represents the equivalent circuit for mode 1 operation. This represents the equivalent circuit for mode 1 operation. This is the actual circuit. You can correlate. So for mode 1 operation, let us assume thyristor T1 is turned on, whereas thyristor TA will remain off. Okay, as soon as thyristor T1 is turned on, now can you say what will be the direction of current flow? When thyristor T1 is turned on, you can see that there are two closed circuits. One is supply, T1 load. This will form one closed circuit. There will be another closed circuit. Capacitor L will form another closed loop. There are two closed loops in the circuit. Okay. So there will be two currents. Basically, there will be two currents. The load current, IL represents the load current or I0. Here it is shown as I0. The I0 will take path from Vs plus along T1 through the load, which will end the Vs minus. This is the direction of load current I0. And whereas the capacitor, now the capacitor will discharge because there is a closed loop. Because of there is a closed loop, capacitor will discharge and recharge in opposite direction. The capacitor current will take path. IC will take path C plus along L, D, which will end the C minus. Capacitor current will take path C plus along T1 L D, which will end C minus. This will be path of capacitor current. So what will happen at the end of mode 1, the capacitor will completely discharge and recharge in opposite direction. That is, upper plate becomes minus, lower plate becomes plus. So at the end of mode 1, what will happen is the capacitor current becomes 0, mean that capacitor will be completely recharged, and voltage across capacitor becomes minus EDC. Like that, current through the thyristor IT1 equal to load current I0. Okay, so at the end of mode 1, the polarity of voltage across capacitor will be like this. Upper plate will be minus, lower plate will be plus. This will be polarity of voltage across the capacitor at the end of mode 1. Okay, so this will be polarity of voltage across capacitor at the end of mode 1. Okay, is it clear to you? Anybody has any doubt on this mode 1 operation? You please clarify now itself. Are you able to understand the main circuit and mode 1 operation? Okay, so I will move to mode 2 operation. Now let us assume that the auxiliary thyristor TA is turned on. Auxiliary thyristor TA is turned on. Once auxiliary thyristor TA is turned on, what will happen? The capacitor this T1 capacitor TA will form a closed circuit. This 3 will form a closed circuit. Okay, are you able to understand? These 3 will form a closed circuit. So automatically what will happen? The capacitor voltage will be appearing across the thyristor T1, and you know that upper plate is minus, lower plate is plus, mean that the anode of the SCR will be anode of the SCR will be minus, anode of the SCR will be connected to minus, cathode will be connected with the plus. This will be polarity of voltage across the SCR-T1. So anode is connected with the minus, cathode is connected with the plus. So reverse voltage is applied across the SCR-T1. So because SCR is reverse biased, what will happen? SCR-T1 will turn off automatically. So you can see that voltage across the SCR-T1 is minus BS. So that SCR-T1 will turn off automatically. Okay. So here you can understand that the main SCR is getting turned off because of reverse voltage. So this combination is otherwise called as voltage combination. This combination is otherwise called as voltage combination, and we are having a auxiliary SCR. So it is always called as auxiliary commutation. Okay, that's why this chopper is called as voltage commutated chopper. Okay, now you understood how the SCR-T1 is getting turned off. That's the main requirement. Here you have to understand. Once SCR-T1 is turned off, the current will get diverted. The load current will get diverted through the SCR-TA. It will take path from Vs plus along C, TA through the load, which will end the Vs minus. So the load current will take path EDC plus C, T2, that is TA, load EDC minus. Okay. Now once the capacitor is fully charged, that is once again what will happen? The capacitor will discharge and recharge in opposite direction. Once again what will happen is the capacitor will discharge and recharge in opposite direction. Once capacitor is charged fully in opposite direction, the capacitor current becomes 0. Once capacitor current becomes 0, automatically auxiliary thyristor will get turned off. Okay. Once auxiliary thyristor is turned off, the circuit will go to the initial stage. The circuit will go to the initial stage. Now both the SCRs are in off state, so that the circuit will go to the initial stage. So we call this commutation as a voltage commutation or class D commutation or auxiliary commutation. You can see I have given statement. Mode 1, in mode 0, both the thyristors are remain off state. Voltage across the capacitor is plus Vs. Both the thyristors in off state. T1, T are off. Voltage across capacitor is Vs. In mode 1, T1 is turned on, so that there will be two current. Load current IL will take path from Vs plus, T1, RL, Vs minus. The capacitor current IC will take path C plus, T1, L, D, C minus. Okay, that is discharges, and it will charge in the reverse direction, so that EC becomes minus Vs, and as soon as T2 is on, automatically the main thyristor will get turned off, and capacitor once again it will be charged in opposite direction. Once capacitor charged in opposite direction, automatically T also get turned off. We call this commutation as a class D commutation. Yeah, is it clear to you? Can you even say? Can you unmute your mic and say, is it clear to you? Please unmute your mic and say whether are you able to understand. Anybody has any doubt, please clarify. This is also important. In exam, mostly they will ask class C and class D. That's more complicated. Class A is easy, class B is easy, class E also easy. Class C, class D is difficult to understand. Once you understand, it will be interesting. You can easily write. Anyone? Any doubt? ஒன்னு புரியுது இல்ல சொல்லணும் பதில். எதுவுமே இல்லைன்னா எப்படி தூங்குறீங்களா எல்லாரும்? இருக்கீங்களா இல்ல?
புரியுது
அப்பா ஒரே ஒரு கேர்ள் வாய்ஸா ஒரு மீதி பேர்லங்க.
புரியுது
ஓகே, நோ டவுட்.
சார்.
ஓகே, என்ன
சார் வீடியோ நாட் ஆடிபிள் சார். சார் பிரசன்டேஷன் ஆடியோ வந்து நீங்க மியூட் பண்ணிட்டீங்க. உங்களது மியூட் பண்ணிட்டு அதை மியூட் அவுட் பண்ணுங்க சார். அன்மியூட் பண்ணுங்க சார். வீடியோ கேட்க சார் இப்பயும் ஆடிபிள் இல்ல சார், கேட்கல சார். பிரசன்டேஷன் ஆடியோ மியூட்ல இருக்கு சார்.
கிளாஸ் டி காம்படிஷன். நெக்ஸ்ட் வில் கோ டு தி கிளாஸ் இ காம்படிஷன். இதுல கிளாஸ் டி ல யாருக்கு டவுட் இருக்கு ஏதாவது? ஷால் மூவ் டு கிளாஸ் சி. யூஸ்டு டு டிஸ்கிரைப் தி கிளாஸ் இ காம்படிஷன். கிளாஸ் இ இஸ் otherwise called as external pulse commutation. ஆக்சுவலா நேம் எல்லாமே ரிலவெண்டா இருக்கும் உங்களுக்கு. பவர் எலக்ட்ரானிக்ஸ்ல பாத்தீங்கன்னா ஒரு அட்வான்டேஜ் என்னன்னா நேம் எல்லாமே இந்த கான்செப்டோட ரிலவெண்டா இருக்கும். திஸ் இஸ் otherwise called as external pulse commutation. E ஆரம்பிக்குது பாத்தீங்கன்னா. How it operates? So as usual here this supply SCR RL is the main circuit. This is the main circuit. Additionally we have one transformer called as pulse transformer. Additionally we are having a transformer called as pulse transformer. This is used for switching off the SCR. So the primary of pulse transformer is connected with the supply. Secondary is connected with the SCR. Okay, this is primary, this is secondary. So what will happen? Normally SCR will be in conduction. The current will flow like this from supply through SCR T1 through transformer RL, which will end the EDC minus. This will be path of current. If you want to turn off the SCR T1, what should be done is external pulse should be applied. An external pulse should be applied to the primary of the pulse transformer. In turn, what will happen? As per the principle of mutual inductance, an EMF will be induced in the secondary. You can see that the waveform in the secondary also similar. The waveform in the secondary also similar. It implies that the cathode of the SCR is connected with the positive, anode is connected with the negative. So what will happen? Once cathode is connected with the positive, what will happen? SCR will be reverse biased, so that the SCR will get turned off. Okay, we call this concept as a class E commutation or external pulse commutation. Here you can understand that SCR is turned off just by applying a external pulse through the pulse transformer. Is nothing but it is just like ordinary transformer. The main difference is in the case of pulse transformer, the turns ratio will be always 1:1. We have studied power transformer in detail in machines 1. There the turns ratio can be anything, depends upon stepping up or step down of the voltage. But in the pulse transformer, there will be no stepping up or step down of the voltage. The main purpose of pulse transformer is for isolation. It is mainly used for the isolation. It will not step up or step down the voltage. Okay. So here the input is a pulse signal, not the continuous AC signal. So here input is a pulse signal. So output also secondary, across secondary also will get a pulse signal, so that the SR will get turned off. So this is called class C commutation. Last one is class F commutation, which is nothing but natural commutation. This is nothing but natural commutation, where SCR will turn off naturally at zero crossing, followed by it will be reverse biased. Okay, so we can understand that the commutation class can be classified broadly into two, as natural and forced commutation. For AC input we will have a natural commutation. For the DC input we will have a forced commutation. Under forced commutation we have 5 different types, class A to class C. We discussed in detail about all the types. This is an important topic in the SCR. Okay, in fact with this main topics on the SCR is over. I think anyone can summarize what are things we discussed so far. Anyone unmute and summarize what are things we discussed so far in SCR. சொல்லுங்க பாப்போம். யாரோ ஒருத்தர் நேம் சொன்னா. நேம் big question will be asked in university exam. You can answer easily. Okay, and I think most of you not touched the book, even advised so lot. And I think better Monday I will ask few questions. Those who are answering for them alone I will give attendance, otherwise I will not give attendance. It's meaningless, just like seeing something without concentration or without involvement. I'm telling repeatedly, the subject is very tough. Once you got failed, that's all, your life will end up. But still you're not serious. Except very few. See how she is answering. It shows her involvement. It shows her involvement. Monday onwards I will ask questions. Though not answering, I will mark absent. Absent attendance absent mark பண்ணா உனக்கு என்ன கான்செப்ட்? Actually the SCR concepts is very wide. If you open the book you can see that it is given more than 100 pages. A lot of concepts to study in the SCR. But as per syllabus, these are the few important concepts you have to study. I have covered as per syllabus. Apart from this, a lot that you can, if you are having self interest, you can prepare on your own. You have few more important concepts also, like series and parallel connection of SCR. That's another important concept of SCR. Name itself indicates. What do you mean by series connection of SCR? Mean that you have to connect more than one SCR in series. Why you have to connect more than one SCR in series? Or it's a general question. In electrical system, why we are going for series circuit? In electrical system, we are having two types of circuit: series circuit and parallel circuit. Why we are going for series circuit? Why we are going for parallel circuit? Where will go series circuit? Where is need of parallel circuit? Anyone?
Sir?
இதுக்கு ஆன்சர் பண்ணுவீங்க, இதுக்கு பண்ண மாட்டீங்களா? Anyone answer?
டிவில ஆஃப் பண்ணிடுறோம் சார்.
முதல்ல போய் டிவி ஆஃப் பண்ணுவோம், செல்போன் ஆஃப் பண்ணுவோம், லேப்டாப் ஆஃப் பண்ணுவோம், எல்லாத்தையும் ஆஃப் பண்ணிடுவோம். எதுக்கு? எலக்ட்ரானிக் ஐட்டம் இஸ் மோர் சென்சிட்டிவ். So because of lighting there will be a surge, there will be over voltage. So this electronic item cannot withstand even for milliseconds, but the electrical item can withstand for few seconds. The electrical items can withstand for few seconds. Electronics item, that to highly sensitive items like iPhone, first you have to switch off. If you have iPhone, you have to switch off first iPhone, then you have to go TV. Like that you have to give priority because based upon the sensitivity. So it means that this electronic circuits basically need a protection against surges. It is applicable to SCR. So we have to protect the SCR against the surges. Surge we call as a dV by dt and di by dt. That is rate of change of voltage and rate of change of current. How we can do it?